All right. So I think till yesterday, everyone had a good idea that how to manipulate Excel files using. I think we were doing the Excel wins yesterday. But what we have not seen yet is a very good data analysis library and data manipulation library in Python called Pandas. It is very useful if you are dealing with very large amount of data. Even with small amount of data, it is good. I mean, basically it eases a lot of things because the way it handles data, Pandas, is the same. I mean, the way you handle it in Excel, right? So basically, any data set that you give to Pandas is treated as a spreadsheet kind of thing. Not all, but let's discuss what kind of data types are. So anyway, just wanted to give you a brief of what we have done so far. So we have seen in and out of programming language, right? This Python programming language. So we have seen almost every aspect of it. A few more aspects we will see as in the remaining few stuff, whatever topics that we are left with. And once we learned that, we tried to see some basic, networking stuff, that how request and response is sent from server back to the client, right? So, and we did a basic web page scraping, right? And then we did some basic data manipulation. Uh, in this, uh, we talked about few functions, and then we discussed about NumPy, and we saw that NumPy allows us to handle large data in very efficient manner because all the operations are vectorized, right? Then we have done CSV and Excel file handling using Excel links, right? So basically, if you want to create your own macro without using the VBA code, you could definitely do it very easily using Python, right? So, and now what we are left it is with, like, these, after these four topics, these three topics, these three things will be fully, be capable to do most of the data scraping that happens on the web. Whatever data is available on the web, you'll be able to scrape that in some way. You will be able to store them, right? Because you'll know how to parse, and you will know, since you will know advanced data manipulation and file handling. Basically, you could do any type of automation that you would like from the data angle. So anyway, and then we will ultimately put it all together, all of this together, to see some of the advanced examples that we can take from our own sector, power sector, right? We would take some data from different power sources, and then we would do some advanced data manipulation to create some basic reports, right? So we will have an idea of how to take it from beginning to end, right? Anyway, let's start. So a brief introduction to Pandas. It's a data manipulation and analysis library, right? You can explore your data set in any way you would like, right? Since it is available in the form of a spreadsheet, just like your Excel spreadsheets, the same way data is available in data frame, right? And then you can explore it. And can read from multiple data sources, right? So if you have Excel files available on some particular place on the web, just let me allow time. Yeah. So let's see if let's say I have this particular uh, data source copy and I paste it. Right. You will see that I directly got a download of a file. Right. So basically, the data itself was available on this particular link. Python could read this data directly, right, without you downloading it and doing something else. Let's say you had some generic link here where there would be some date. Let's say November 2020, right? Something like this, and you get data files from there. So you could just change it to December, and you could do your automation. Right? Anyway, so this is one thing, and then it can obviously read from your CSV data, your XLSX data, and Then there are ways to read from database as well, right? But we will obviously see the later fetching from APIs, and we will see how to fetch from database as well. Okay, not seeing written it here, right? But I think after that you'll be able to do any kind of data automation if you like, right? You will be capable to do that. So anyway, it can read from multiple data sources, and it is built on top of NumPy arrays, right? So uh, NumPy arrays actually work. I mean, when NumPy arrays or NumPy code is executed, it is converted into C-level bytecode, right? Basically, it is converted into C code and then which is executed. And C code, since is very fast, then pandas, then that is why we don't use traditional lists from Python and generally prefer NumPy arrays, right? And pandas use NumPy arrays, so even it takes in all the features of NumPy arrays and builds on top of that. So it is even more powerful, right? So anyway, we will read this data set. We will see how it can read from multiple sources. But before that, let's just see the kind of data types are available in uh, data frame, right? So as we saw in NumPy, we had one data frame called ND array, right? And we could do any kind of operation on that data frame. So there was only one data type, right? But here we have three type of data types, of which two I have listed here, which are the main types that most of the time we will use, because our dealing with the mostly with spreadsheets, Excel files, databases, or any kind of data that we would want to have, we would want to work with, would be covered in these two types, right? So first data type is series, right? Series is a NumPy array-like object. It's not a NumPy array, but it is like that. So it has very similar properties of a NumPy array, and we will see that. So, and then we will see how to create a series, right? What are the differences, and how it works, locating elements from the series. So just the way we have seen how to get elements from lists, data, dictionaries, right? And then other types, right? So similarly we'll do, and we will do some operations. Okay. And the second data type is called data frame, and it is basically a collection of series. So you could say that there is basically, if just I try to represent it, a list containing a lot of series, right? So a data frame is something like that. And if you consider a series, right, as a whole column, right, then a collection of series would be a collection of columns, and then that would represent your spreadsheet kind of thing. So anyway, we will see how to create data frame from multiple type of data types as well. One is NumPy array, and then second is lists. So we will see how we can do that, and then we will see how to locate and subset elements from the data frame, because that is also a useful feature. And then we can do operations on data frames. Right. So let's get right away into the coding and practical session. Basically, I think last time I used our own Sublime text to do all of those kind of stuff, but we'll go back to working with these things, right? I mean, the Google Colab. Let me just allow someone else, right? So we will again work with Google Colab, because I mean today we don't have to see those Excel kind of things that we wanted to see yesterday using Excel links, right? We don't want to see macro works today, so we will just use this, and this is easy to use. So first of all, what I will do is I will upload those files that I have shared as part of this session, right? So I have shared these 4 files. I hope everyone has it. If they don't have, kindly please, if someone has it, kindly forward that mail to others. Basically, I will just upload these 4 files here because I want them in memory so that I can directly use them, right? But until the time they get uploaded, let's start with pandas. Okay, so the first thing I will put here is a comment, and I will say exploring. So one more thing, the third type of data frame here, which you will hardly use any time, is called a panel, right? And so a series is basically a 1D, one-dimensional object. Data frame is kind of two-dimensional object where you have rows and columns. And then the third type is panel. So we would rarely see that kind of data type, but that is again, you can use it to uh, explore multi-dimensional data as well. But in our examples, mostly we will be using with some kind of tabular data, right, from database or any sheet. So we will not be using panels. So let's explore these two data types, exploring the series in pandas. So pandas, I already know. I mean, if I just do a small search about pandas, right? We've already done that. The documentation is here, pandas.pydata.org, and uh, something you can see it yourself. There is a big API reference, and it is one of the biggest libraries out there for data analysis and data manipulation. Okay, so let's start with that. So first, let's see how a series works, right? So what you do basically, let me type a comment here. How we define a series is that you import the module, right? I don't need to specify that, but I'll just specify how to do how to write that. We'll say pd.series, right? And then open close bracket, and then I will pass a array or list here, right? So first, I will need to import it. I will say import pandas, right? Pandas simple. But again, uh, here you can see that it already suggested me that use it as PD, because in the community as well as online, wherever you will see the examples, you will always find pandas being aliased as PD, right? So we will also use it as PD, and then the series can be defined as, here the series, you have first data, right? The data can be of either a numpy array or a numpy 1D 2D arrays, no, only 1D array because it's a series, and then a index, right? So I will tell you what that index is again, since you will be able to get it through some way, right? You will be able to index it. So there is one more parameter called index, which you can specify, or it depends on you, right? And then there is D type. So basically the data type of this particular series, right? So you define all of these, and then you define a series, right? So let's see. Uh, I will just import NumPy as well because I want to use one of the arrays. I want to create an array of NumPy and use it here, right? So let's say my data equal to, right? I say np.array, and since a NumPy array can only contain homogeneous kind of data types, so I'll just put a few data points here, all as a string type, right? Let's say this. So now this is my array. Okay. The array is passed a list, and then this particular thing is now a ND array. Okay. And using this ND array, what I can do, I can create a data frame, and call it. Uh, in fact, since I'm creating a series, right, I'll call it a series, and say pd dot series, right, and pass this data. That's it. The rest of other things I can pass, or it depends on me if I want to pass or not pass. Right? So just a second. That's fine. So now I could print it and see what it looks like. Right? Let me try and print the data as well so that I can see the difference between the both kind of things. Now I can see that when I printed the data, right, a simple array, it printed me this, 1D array. But when I printed the series using the same data, you can see that this thing is printed here, and 0, 1, 2, 3, 4, some index kind of thing is also printed here, right? So obviously I did not define, passed an index variable there. So it took it like that, but I could definitely pass an index and call it, let's say range of, since there are 5 values, so I can just say 6 to 10, let's say, no? And then you can see that your index is invalid here. No, it is not invalid. Sorry, that passing it at the wrong place. I will have to pass it here, right? Because it is to be passed to the series one. Hmm, length of pass values is 5, 8, 9, 10, and then uh, index implies 3, 6, 4, 11, right? 11. So now it is 5. Now I can see that my index has changed. It was earlier 0, 1, 2, 3, 4, 5, and now it is 6, 7, 8, 9, 10. So whatever I have passed as index is now given here. Obviously, I mean, why would index be used? To access those elements, right? You can access those elements, we will see. But you could specify your own index as well. Okay. So now that, I mean, we have created one from NumPy array. Let's see if I could directly also do something like that. Let me just copy it and paste it once here. I'll just say that create a series using a NumPy array, right? And then I will say it here that create a series using a normal list, okay? A simple list, right? Only that the list should have homogeneous data types, right? Since we have already seen that it can contain multiple data types, but here it should have homogeneous data types. So here I will pass this, right, directly, a list. Probably I will say it A1, B1, C1, D1, B1, right? Just to have a distinction. And here I can say 11 to, let's say, 16, right? Again, 5 values. And here I can say this series 1, and data I don't need. So I'll just say series 1. Now if I see, again, I could create it from a list, right? I could simply pass a list, and then you could create a series, right? So this is how you create it from simple list as well as this one. Now let's say I wanted to create a series, okay, using a dictionary, right? So currently I'm using a list. I've seen how to create it using NumPy arrays, and then let us see how to create it using a dictionary. So create a series using a dictionary, right? So it should make sense to everyone that why we would be able to create a series using a dictionary is because of index, right? So basically it's like index value, right? Index is like a key for anything, and then you have some values, right? So similarly, you could just define a let's say dict data, right? Dict data, and you could use this dictionary to create your own data frames. I'm sorry, it's a series. So you could create your own series, right? B equal to 1, and then C. Okay, now this is my dictionary. I can create a series simply by passing this data. So I can say again series 2 equal to PD dot series, and then dict data. Now I don't need to pass an index here because these uh, these keys will be taken as index values. Right? So I did not print it. Let me try and print it. Any issues, anyone? I will just mute Dave. That's not a problem, right? So let's see what series 2 looks like. Again, it looks like this key were taken as indexes, and those values were the actual values of the series. Right? So dictionaries can be used to construct indices. right? If you have already some indices, then you could do it. Obviously, you could specify your own index, right? Obviously, if you want it, index again equal to range 0 to 3, right? 0 to 0, 1, 2, it will put. So now you could see that 0, 1, 2. Obviously, there were no values for 0, 1, 2. They would remain with A, B, and C, right? So that is why it did not print here. Okay. But if you said uh, not this, but something like this, only A, right? So what you will see that only A was, only A came here, right? And the rest were. But let's say you put B and D and C here, right? You are using more indices than actual values. So what will happen that it would create the one which does not have to NAND. That's what we saw when we were, trying to add a different index. Okay. I hope this is clear to everyone. We can create using what methods. So why we are even looking at something like this? They any problem to anyone? I can see some lines on my screen. Can I remove them? Anyway, see these lines have come. I don't know how, but anyway, let's proceed. So why are we even looking at this is because we would often be in situations where we have an numpy arrays, right? We might be in situations where we have numpy arrays and then we want to convert it into a series or a data frame, right? Or we have some lists, right, that we have extracted from some way, right? And then we want to, and then we have some JSON kind of data also, right? So if you have seen JSON data, it is very close to dictionaries, right? It looks like this. So there is a key and then there are values. So you can pass your dictionaries, the JSON uh, data to your pandas, and then that also can be read easily. So I mean that is why we are looking at all of these types. Can someone, Dave, can you remove these red lines here?
I don't know how this got him because I was just zooming the screen while just checking.
I'll just make you host for a minute. Right. Can you remove these lines? Otherwise, we will have to keep it throughout the lecture, and it might be disturbing to some people. So, okay, no issues. Can you just put me back to the host?
Not removed.
Okay, anyway, so sorry everyone, I think we will have to keep this like, I mean, why, I don't know how this happened, but let's proceed like this only. Again, something happened here. So I'll just erase this. I got it.
Okay.
Anyway, let's proceed. Now let's, so we have seen that how to create a series. let's see how to locate one of the elements. And it works very similar to how lists work or any numpy array work, but let's still see how to work with that. Locating the elements in series. Right? So we have already defined a series above. That series, let's take this one, right? The second one, which one is this series one, right? So we are want to take element from series one. So I can just say series one, right? And then again similar notation to how even the numpy arrays work, and then I could say S0, right? And then this adds S first element series. I'll just run this again. So this is fine now, and then my series is this one. Okay, so my series is this one, and then I can just a second. Series one. Okay, there seem it doesn't seem to work, but let us. Series is fine. Series is known. So series 0 does not work. It works in this one. Right. Right. I got the issue. So let me just try and explain this why this happens like this. So basically, when you are trying to only access one element, right? What happens is that mm, it tries to get it using that index, right? Index, okay. And that index, we are not, I mean, it directly tries to use that number as index, right? So if I say 0, again, it would throw an error, right? And if I say, let's say even 1, okay, 1, where is it? 1. It would again throw an error. But if I try and locate it using 11, let's try it. Or not this. Let me just wait a second. This is correctly defined. This is fine. And this is also fine. So maybe I was doing a wrong notation. It's simply, let me just copy it once. Let me just delete it. Write a new code. And so what happens is that in NumPy array we saw that we need to define a start and endpoint. So let's say this was my array, right? Let's say numpy dot array, and I would say 1, 2, 3, 4, 5, right? And here I could, if I say 0, it would give me the element, right? So it doesn't work the way NumPy works. What you have to do here in Pandas is specify a start and end. How you would subset it? That you would say series 1, and then you would say a start, and then you would say an end, right? So you will have to define a start and endpoint to retrieve those elements. Again, this is not how it used to work earlier. I don't know why it does not work that way. Maybe something had changed in the pandas library. But earlier what used to happen that you could just give directly the index and it would work in the same way as NumPy arrays work. But anyway, let's try and do something like this now and see how it works. So it gave me the first and second object. So this was 0th, 1st, 2nd, 3rd, 4th. right? So it gave me first and second object. Let's say you only wanted to get one. What you would do is just, I mean, you will have to specify it like this, which one you want, right? And accordingly, you would be able to get that. So I think this is one way, and then also the negative index stuff also work here. So let's say you wanted to get all the ones from beginning to end, right? This is how it would happen. Let's say you wanted to get from 3 to -1, then only the last one would come, the fourth one, right? 0th, first, second, third, fourth. In fact, 0, first, second, third, fourth. So you want from third to last. So third one obviously would be this one, right? 0, 1, 2, 3, right? And then only this one would be taken out because the last one is not taken out. Okay, just the way the list used to work. Okay, so anyway, you remember this because that thing does not work. I mean, you would not be able to do something like this because it does not work anymore. It's not the same way numpy arrays work. So what you will have to do, you will have to give a start and a stop, start and the end. Okay. Anyway, so just I'll just print out here, and then the next thing we can see is that how to obviously use something, this index, this particular index to get this one. So what we would be able to do is that, say, uh, series 1, and then something like this. So what it did was, now I could directly index it using these labels, right? These whatever the index which is given to this, I could use directly that, which is, I have defined here, directly them to access those elements, right? I could say 12, 15, let's say, because 15 is also there, so I will get even. So this is another way. If you want to use the indexes, the index names, right? These are the index name that you have defined yourself. Even, if in this one I wanted, I could have got like series, if I do series 8, right? Series 8, then I would have got that particular, value, right? So I hope this makes sense to everyone. If you want to get one particular row from, the a big list of a big spreadsheet, right? You would, if you know the index number or name, then you can get it, right, from a series and from a data frame. So let's say you wanted to get multiple ones, so you could say 8, 9, right? You would get multiple. Uh, you will have to pass this as a list, right? So if you have to get multiple elements, you will have to pass it as a list inside this index. Okay, now you would be able to get it, right? So you were able to get the eighth element. I mean, an element with index 8 and an element with index 9. So whatever index you put here, you will be able to get that, right? So I mean, I hope you will be able to find that where it would be useful. But anyway, let's proceed. Let's say you wanted to uh, retrieve an element which is not there, then it would obviously throw an error that we have already seen. So let's say 11 is not there in series, that we have already seen that pandas does not work it that way anymore, right? So I hope this does not confuse anyone that, since, I mean, it intuitively should work like that, but it does not. If you want to get multiple rows, you will have to pass like this. If you want to get multiple rows using the positions, right, you will use like this. But anyway, series is generally, I mean, useful in, when you are looking at it at individually. I mean, basically you want to analyze one columns, but generally it doesn't happen that way, and we will be analyzing multiple columns together. But anyway, we have got an idea of how it works, so that should be fine. I will just delete this, and then I think we can proceed further to see how data frames work, because that is the core of the Pandas library, and that has the main functionalities. So I will just say here that um, explore the data frame data type information. Okay. So first again we will do the same thing. So what we have done, we did uh, okay, we did not do some operations, but we could do it, right? Obviously, I mean, here there is something, so you could multiply it by something, right? And then no, that those will not be multiplied. In fact, those will be repeated two times because those were strings. But if those were numbers, they would have multiplied. So you could do some kind of operations. I don't think we need to get into it. When we will be reading big files and we will be doing such kind of operations there, we will know. Okay. So we'll just skip it here and then go to data frame. So let's see first how to create data frames, right? Data frames very similar to series. It also, if I have to just copy it here, I just copy. So this is how it works, but it's just a data frame, just data frame. And now this data can again be, I mean, it can be a numpy array, it can be series, it can be dictionaries or constants. A scalar, it can be a simple number as well. So it can take a variety of inputs for you to create that spreadsheet kind of object in memory of Python. Okay, so it can, let me just define it here. It can be created using lists, right? It can be created using dictionaries, and then it can be created using pandas series as well, right? I'll just call it pandas and series, and then numpy arrays, right? And then obviously using another pandas data frame, right? You can use one data frame to create another. And now let's see the power of it. But before that, let's try create one of those data frames. So obviously this series could be empty. No, I mean, uh, in fact, let's try and see what happens when I say td.series. What happens is that it creates an empty series. Right? There is nothing in this series, and obviously you could manipulate it because it's a mutable thing. Right? So similarly, if you wanted to create an empty data frame, why would we ever create an empty series to manipulate it later? But uh, not generally useful until you are creating your own data to be put into this, and you have to iterate over each of the elements to create this series. Until then, it's not useful. But let's define a simple data frame called df. Here we had defined series. Pandas data frame. It also takes the data. You can specify index, and then you can specify the data type of that. Right. So now this is a simple one. If I print that df and see what it looks like, it would be just something, right? Here something. In fact, it contains nothing, right? So it is an empty data frame. But let's define it with some values. In fact, let me pass 1, 2, 3, 4, 5 here as list, right? And see how it looks like. Now we can see that it looks like a table, right? Table has some, this index. So if I just quickly open an Excel sheet, I think this will be understood better. That, this 1, 2, 3, 4, which is already there, it is called the index of this particular row, right? This particular row has this index of 10. And this column, and these are called column names. So this particular column has a name of A, this has a D, right? Unless we specifically specify, right? We can specify here and specify something here and use it as our indexes. But before that, in an empty thing, you can see that, these are the indices, right? So the same way this works here, right? If you print 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. this is exactly, what is shown there. Right? This is exactly, and obviously in Python everything starts from a zero, so it is given zeroth column as well as starts from zeroth index. So this is how a simple you could visualize, right? When we print the simple series, it prints something like a table, but not exactly a table. And here we can see that it perfectly prints like a table itself, right? So it in more sense is like a table, and then whatever is inside of it, right? If I just so I told you that data frame is a collection of series, right? If I just say type of I will show you how this works, but if I just say um, and in fact say I love, we have not seen these functions yet, but mm, we will see. So I want all the rows, right? And all the rows, and I want the first column, right? Only the first one. So something like this should work. So it says that it's pandas.core.series.series. So basically this particular one, what I've said that all rows and first column, right? So it says the type of this is a series. Okay. So it's a collection of series. Sorry, just getting some calls. Uh, anyway, we'll take later. So let us proceed and see. Now here we have taken a simple list, but yesterday we saw that when we read a CSV, that is generally taken it in as list of lists, right? So let's see how we can use lists of lists to create one. So let me define my data set, and data set can be something like this, a list of lists where you know first element is, let's say, Anup, and second thing is its age, right? And then I can create more elements, right? Let's say Ram and say 17, right? And then someone else, Rama, and say 23. So this is my data set, which is list of lists. This is exactly how a file will be read in CSV formats to you. Okay, so now you have that data, and you want to create a data frame so that you could do use these powerful operations to do some data analysis, right? So what you could do is simply pd.dataframe, and this PD, I mean, just reiterating that is because we are reporting pandas as PD. So pd.big data frame, we will pass this data set, and I mean, we could let's not pass anything else right now. We obviously saw that it takes other some types of things as well. One of them is index, other things columns. So there is one thing called columns, but let's see, even if we don't specify it, how the data looks. So let's say your list of lists, you will see how it looks like. So it will look like this, right? A table where there is a zeroth column, there is a first column, and then there are some rows with indices 0, 1, 2, and the actual data that was there with me, right? So what I mean, everything is fine until now. These indices are fine, but let's say I wanted to give these columns headers, right? Headers some names. So what I could do was there I could specify the columns. So there are two things here. We have already seen there is one thing called column and one thing called index. So whenever you want to specify the names of these rows, right, the index of these rows, you use the index column as we have already seen in a series. But whenever you want to use names, give names to the columns, you use the columns. Okay. So I can say columns, and then that column itself should be a list, right? Because I mean, that is the way you will put it here, almost always, right? So you would say a name and age. Now this particular thing should have these column names. So we have seen how I could change the column. How I could change the index? Let's change the indexes as well. And I could obviously say A. So there are 3 rows. So I could say A, B, C. So now my DF is A, B, C, Anup, Ram, and Rama. And now obviously here I would be able to locate it. Let's see that, but before that, let us also see how to create it using the dictionary. Let me just write it here. Create a data frame using a flat list. Okay. Here I will write uh, each column of a data frame is a Pandas series. Okay. Pandas series. And then here I'm trying to create it using list of lists. So create a data frame using list of lists. So we have done it now, and let's do just one more thing, and then let's proceed with manipulating data. Create a data frame using a dictionary. So now here when we were trying to use a dictionary to create data, right? These were passed as arguments by default, right? But when we will create a data frame using something like that, a construct like that, what we will do, so here we had only one value, right? We were passing in only one value to the index. And let's see that, and then I think it will be more clear. Then we can make a comparison between two. Let me define it, again, dictionary data, let's say dictionary data, and let me again define something like this only. So I'll just say name column where the name is the key, and I have a list of values called Anup, right? Ram and Ram. So basically what happened is that I wanted to create the same thing. So I, defined a dictionary with a name, and then I gave all the values which were related to that name in a list, right? Another key I could create was the age, right? And then what, similar thing I could do, another list where I could pass the values of age, right? So now when I would pass this to a dictionary, Pandas data frame, right? Let me create it, uh, dfdict, okay, and I will say pd dot data frame, right, and frame, and then pass it dict data, uh, dict data, and then if I print it and see, in fact, here I don't need to print, I can just call the variable like this. So I can say that I have created the same thing, right? But if I put a comma here, again, I would see that a data frame can take an index. So I can pass it an index, right? I know there are 3 rows, so I could pass a similar A, D, and C. Now my DF dictionary is same as this particular one I created using list of lists. So you see the contrast between creating it using list of lists. You had to specify your own column names. Just the same thing you have to do here, right? But you have to separately give them and associate a key with it. If I had to compare it with the series one, right, I saw that since I was only passing one value, right, it was a 1D kind of thing, one dimensional thing. If I would just pass this, I mean, obviously, let's try it, right? 0, 1, and call this 1, comma 2, right? And call this 2, comma 3, and see what happens, right? Big data. So we will see that uh, those lists themselves were assigned here, right? This is not ideally what we wanted, right? So anyway, even if you pass 4 elements, it would keep, consider it as a single thing, okay? So it would not create into a data frame, but would keep it as a series itself. So anyway, now I think this would be clear that what happened here. One. 2 and 3. Let's go back to our example. So here we were able to do that, I mean, whatever we wanted to do. Okay. So what else can we do? We could, obviously, we have defined indexes, and then we could obviously create it using more constructs. But I think this should be enough. These are all the types of constructs that we will be mostly using. So let us see how we can uh, do selections. Okay. So let's say I wanted to get this particular column, right? So getting a column using column name. Okay. So let's say I wanted to get this column. Since I have a column index, right? I could get this column using this column index. And that is why it is very easy to use a data frame, because it allows you for such kind of operations, right? If this was a very long list, then using a normal list or something, it would be very difficult. So what I could do was say that print, I mean, df, right? Df dictionary, and just say names. Right? What it would do is it would give me that thing, right? And if I would just try to see the type of this thing, you would see that it is a series. So again, this satisfies what I said, that basically a data frame is list of, not a list, collection of series, where we know that what all things we can do with a series. So basically we can take out each of those columns one by one like this, and then we could implement something like this, something like this on this series. Okay, so one of the operation was, let's say I want to multiply it, right? I want to just repeat my name, so I can see that Anup, Anup, Ram, Ram, and Rama, Rama was just multiplied. So anyway, I can do all those operations now, which I could do on a series, right? Uh, let's say I wanted to add one more column here. So generally, let's say there were two numbers in, and I would ask you to total them and then add one more column. Just the way we saw yesterday how to do it using Excel link, but let's see how to do it using Pandas. So what you could say is, now you have a name. Let's say you wanted to add one more column. Add one more column called age. Age added 5. Okay, age added 5. So you will add 5 to this age and present it here. Right. So what you could say, you could again, if you wanted to access that, what you would say something like that. Let's say you have already had that column here. What you would say age added 5, right? This you would say. But you don't have it now, right now, so you will assign it actually. You will assign it with what? The age one, right? So you will say, because why you could assign it the age one, because I mean, you could take it out, and since you want it of the same length, so you would take the age. And then obviously in age, what you could do was just add a 5. So let's see if this works. Okay, why this 5 work? Because I mean, it's just Pythonic way. Basically, what you otherwise would have to do is create one more, I mean, series, right? So what you would have to do is do pd dot series, right? And then there you would have to say 5, 5, 5, right? This you would have to do, and then you would have the same result, right? If I did df age added 5, what I would see is that uh, not a number, because Let's see. Let us verify why this works like this. So if I now see my age, right now it is perfectly 32, 22, and 28, right? 5 is added to each of them. But if you wanted to, you know, add it using the same way that we did, let me just, you will have to first, create it into a data frame. So because this particular thing here uh, obviously corresponds to a data frame, uh, we saw it's a series. No, it's a data frame because it has a column index, right? So you would do something like this. But anyway, let us remove this for now and just see that if you wanted to add 5 to each of the columns, then you could do something like this. Uh, anyway, we will see that as well when let's come to, in fact, let's come to that. Um, so let's say you wanted to add a series like this. What you would do is that you would create pd.series, and then why it did not happen was because its index was not same. So what you would say is that let's say 5, 5, 5, right? And then the index should match. So you will say index equal to A, B, and C. So I mean this particular thing is again, if I just copy it here, or let me just copy these things here and paste it here, right? Now if I do the same thing, now it should work. Right? Now if I see df age underscore added 5, now it should make sense. This work. Because last time what happened when I defined a series using this one, my index was something else. So if I don't specify again an index here, right, what would happen is that uh, it might give me those NaN numbers, right? NaN, because those indices did not match, so it would not be able to add it. I hope it was clear. Okay, let us proceed. So other things we could do is, I mean, very similar. Let us before uh, going to that, let us examine how it looks like now. So you have added one more column called age added 5, which is basically just 5 added to this age. Okay. So I think by now this should be enough for you to understand how it works. Okay, one more thing. Maybe if I wanted, I have seen how to get columns, right? And I have seen how to get it this way. Right? But let's say I wanted to get 2 columns out of it, again subset 2 columns. So I would just say df, right, this way. I would say uh, name and then age. Okay. If I just see that, I would see that only name and age. So I'll just say index multiple columns. And now let us see how to index multiple rows, and then we will be good to go. Index multiple rows. So we have already seen how we could index by specifying the index, right? So let's say I say df and a, right? What it would do is that mm, sorry, because the error 8 should not give this error. Anyway, let's just see that multiple rows. Yeah, so let us first try it using positional uh, indexes, right? So I was trying to use these particular indexes, but I don't know why it does not work. But I mean, let's see that. Let's give it more time. But before that, let's see how to simplify it using the positions. So basically, this would be zeroth position, this would be first position, and this would be second position. What I just said is that just give me from 0 to first position, which would be only zeroth position. If I said 0 to 2, it would give me first two positions. Okay. So uh, this is, I mean, this should not be very confusing, because whenever we want to get columns, what we do is that, okay, got it right. So what we were trying to do when we were, doing something like A, we were trying to access a column A and not a row A, and that is why that was giving an error. And A, since there is no column called A, it was throwing an error. But when you want to go for a row operation, right? You want to take a row, you specify not in something like this, but in something like this. Okay, something like this. You again specify a start point and an end point, just the way you did with the where we were using the series, right? This just the way you were doing with the series, the way you would do with the data frames as well. Okay, so this is how you could do multiple data frames. Okay. Let's say you wanted to uh, drop some rows, any row. Okay. So you could also do that. You could delete that. And in fact, let us see it using a file. So let us quickly read a file, and then on that, let us do those operations. Okay. So I'll just refresh it and see that my files should be uploaded here. Right. So my files, uh, no thanks. So I think I had uploaded these files here. I'll just go here again and see that where exactly my files are. Home, etc. They're not here. Anyway, then maybe. So I think I will have to start one more session, because uh, I actually forgot in which of those folders that file was placed. Right, it is some default folder. I'll just see it here, and then I would be able to know. So here I go, right, and it is just allocating me some space. Let's wait for a minute and just resolve this first. So now it in sample data, right? So in sample data, and this was what? This was again, no idea which folder it was, right? Maybe some folder it was. Okay. So anyway, create, let us in fact upload something in the home folder, right? And just upload it here, because otherwise, I mean, we would not be able to find it. So I'll go to the home folder and use it from there. I don't know if it could be read directly, but I don't have any other idea, any other way to know. Otherwise, I'll just start it from here. So I'll just complete this one and say working with pandas part 1, and then use another of those. Just paste it here. In fact, just create a new one and close it, this one. And because why I have to do this is because when I upload in the default location, I can directly access it using names, right? Directly using, I don't have to give a file path to it, and that becomes easy for me. In my own folders, I generally, it's easy for me to know the path, but when we are working in Google Colab, there might be some confusion. So anyway, just upload it here, and in here uploaded files will get deleted. That is fine. It comes here. Right? So in sample data, other files are here. Now let me just put this like this. Part 2, IPND. So just remove one of this. And now I'm good to go. So first import pandas, pandas and reads. So let us start that. So we can say that pd dot data frame. Sorry. Let's see how to read a CSV. So pandas read CSV. Right? We can search something like this, and obviously there is some function called read Excel, as well as there would be something called read CSV. Right? So in fact, let us see it here. I will first import pandas, import pandas as PD. And I think I've already told you, when you are not able, you're not sure that what all things you could do with something, then you could just do a dir, right, PD, and that dir will give you all of the things that you could do with it, right? So I could do something like read CSV. Okay, so I have a read CSV function, right? I have a read Excel function. I have other functions. I have read HTML, read FFW, feather. So many things are there. SQL table, SQL query, read table. Right? You get the idea that how powerful it can be. It can read a clipboard as well. Whatever is you have copied, it can read that as well. So anyway, I have to read CSV in Excel only here in this particular example. So I will do that. Before that, I will say that let's say first I would want to do something with the Corona stats CSV, right? Because it contains some numbers. Let me just open it once and show you, right? Here, what we could do is do some basic operations using these numbers, right? All of these numbers, and we could see how we could subset some of these numbers, right? So, and obviously we could then sort it, right? Do something with the missing data, right? And do all sort of data manipulation things that generally we want to do. So let's proceed and read this one. So we can see that here we have some blank columns as well. Let's see how Pandas handles it. We have blank columns here also. Anyway, so I will just say that my stats data, and I'll just say it as pd dot read CSV. So we've already seen that read CSV works. I can say corona, stats dot CSV. So okay. So now if I see stats underscore data, and then I do nothing and just want to see it once, right? I will see that something is printed. Like basically whatever data was there in here has now come in the memory of our uh, whatever the system is, okay, in the Python's memory. Now what you could do, let us start with directly with the operations, right? Which would uh, give you an idea of the kind of things you could do with this. So, okay. So let us first see, right? I think what we can see here is that all of these numbers are somehow text, right? So if I would say that give me some information about this data set, right? Stats data.info, right? So there is one function called info. What it would do is just summarize the data and tell me what it is, right? So here it says that I have some 18 columns, okay, and there are some column names given, and it says that only one of the data, the number column, basically the index, right? How it is defined here. 1, 2, 3, 4, it is defined like that. Only that one is a float 64 object, and rest all of them seem like text objects, right? So now we know, we have seen that for any data manipulation that we want to do with the objects which are characters, right? Right, but should be an integer or float numbers, right? So you will have to first change that. Anyway, so I'll just put it here like just describe or summarize. Describe the columns of the data. So, this can always be the first step of your process, because how it is being read into Python is where it should start from. So, let's say your objects were read directly as integer 64 or float 64 or double 64. Double 64 is not there, but just an example, or a boolean or something else. So on integer, you will be able to do integer operations, right? Accordingly, you will be able to do those operations, right? Even if those are in vectorized form, you will first have to know what all type of data that you have. Okay. Anyway, so this can be always the first step, right? So now I have seen it. Let's say this was a very large data set, and I wanted to just see the top 5 or top, let's say, some rows. Let me just say show top n rows, right? And then another example, show top uh, m, or bottom m columns, not top, because top we've already seen. Bottom m, again, not columns, rows. So let's say you wanted to see first few rows and last few rows of this particular data set. And since abhi to ye bahut small hai, it is only 216 entries, but let's say there were lakhs of entries. So, and still you wanted to see some n or m rows. What you would do is, I think you could say something like, we have defined stats, right? We would say something like tf dot head, right? So whenever we use head, and we specify an integer n. So let's say you wanted to see first 10 rows from the lakhs of data set, and then last 15 rows, let's say. So you would say stats data dot tail, right? And let's say 15 rows. Right. So from a big data set, you could do something like this just to have a basic glance. Obviously, it printed one of them, right? It printed the smaller one, so I'll just say print this one as well, and I'll just remove it to 5, and I'll just say 6 this one, and print both of them. Right. What happens in Jupyter Notebook is that if you have only one variable to print, like here here we saw that only one variable to print, and you execute the statement, it directly runs, right? Just like it happens in the interpreter. But since, let's say, you had multiple lines here, let me just copy it again and paste it here. Both of these are valid lines, right? What it would do is it would only give the last one, right? 1, 2, 3. So it would only output the last one, with last statement which is to be executed, and the rest it would not. But let's say you wanted to print both of them, you would specifically print, right? Put a print statement each of these, and then it would print both of them. just like it happens in a normal script, right? But I mean, just showing you here because this is I mean, you will be using Jupyter notebooks a lot because that's kind of a standard these days for data analysis and data manipulation, right? So you will do something like that here. So anyway, now we have seen how you would be able to see, just inspect a few things, right, from the rows. Now we can see that it has printed again. If I just run it, I can see that it has printed some first 5 rows here and then some rows here. Uh, since we used two prints, right, it did not format it that way because if you have, let's say, 100 of prints, it would not be formatting all of them in tables. But if let's print it in, different, uh, right, no, print, whenever you use a print statement, it does not format it into a table. Okay, here, let's see. Uh, I just not use print because I want it in formatted form. So I'll just use it. Does not really matter you use print or not because your data is the same, right? Here you can see last 5 rows here, and here you can see first 6 rows. Okay. So I hope this is clear to everyone. Just give you a basic idea of how your data would look like if you did not want to print all of it in this field. Okay. So let's say I can see in my data set that my first row might not be useful to me. Okay. So if I just see this data, I can see that my first row does not really have a lot of numbers, so it might not be useful for me. So let's say I wanted to skip this particular row. Okay, what or skip? Let's do one by one. Skip this particular row. So what you could do was skip some particular rows from the top. Right here, what happened is that I have not I did not specify anything else, right? So when I was doing this pd.read CSV, if I just put a comma here, it will give me all of the different things I could do, right? So it said that a file path I've already given, then a separator. So let's say in that CSV, it was not a comma that separated it or something else. You could definitely specify it. Sometimes you have TSVs, right? Tab separated values. So here you could do /t, then delimiter, and all of the other things that you could specify here, right? Here, one of those things is called header, right? Somewhere you will find it here. Can't really find it. Yeah, here is header, right? Header here it says infer, right? So basically whatever the first row of your sheet is, right, it is directly defined as header. But let's say I did not want it as header, I could definitely say header equal to none, right, and then define my own headers. Now what could happen is that it would not show that column, right, and now it does not really know what's happening. If I just see it here, now the zeroth rows has all of those things, and then Python reindexed it in its own form to show this. Okay, so I think this should be clear until here. I will just change it back because this was just an example I wanted to show you. So let's say your file does not have any headers, right? And it starts from here itself. So you will say there is nothing. Okay. You will say that there are no columns, and then you could define it yourself. Right? So let's say I want to. I did it back and then did the other thing. Now it's back to normal. Okay. And now it's back to normal, and it is again a data frame. So I could create another data frame using a data frame, right? But I could skip it this time maybe. So data frame using another data frame, right? Why I would be able to? Why would I would do something like that? So let's say I read my file. and then I did not want to change it, right? And I wanted to use another data frame on which I wanted to do all the operation. So I would create another data frame using that data frame. I would just say pd dot again data frame, and then here I would just say that stats data, stats, stats data, right? And then here I could say that index columns, all of those types things are there, right? Here you could say if you wanted to skip first two rows, right? You could just say that take all of the rows from first one, right? Because the zeroth one you want to skip, right? And then take all of them. Okay. So dot log and all of them. So this is how you would do it. And if I just wanted to give it some variable, I would just say it's data copy, and then I would perform all my operations on this data. Let's see what this looks like. Hopefully this should run fine. And data copy looks like this. It is again that particular data frame itself, but now that first row has been skipped. Okay. So and skipping a row. Skipping. Right, let's say you had junk data for first 10 rows, so you would just say 10 here, right? All it says that from 1 to end of all rows, and then all of the columns from start to end. I hope this notation is clear to everyone. So now I can do all kind of operations on my data copy, because it also seems like uh, the first row is gone, and now I can do some operation. So let's say again I wanted to uh, do total cases, right? Total cases. So I will have to sum all of this, but it looks like a float. So again, I will have to first convert it into a integer, right? So what I could say was that data copy, right? And maybe, so if I just see what all things I have to do with data copy, right? I could do dir. This is very simple when you're not able to remember what you want to do. It will directly give you all the things you could do, right, with that. So you could convert it into Excel file. You could do a NumPy thing, right? But what I want to do is to uh, get it into a list form, right? Because on list I can apply a map, right? On an iterable I can apply a map. Okay. So anyway, I'm not able to get it here. Maybe it could be somewhere. iLock is there, right? So all of the things are here, which you could do. Iter items, you could iterate over them. Uh, but anyway, I cannot find what I'm trying to look for. To it, it could be to. So anyway, let me just apply this function. What I could say was that data copy dot to dict, right? I could do something like that. And then what I would be able to see that all of my data frame has now been converted into a dictionary, right? Where all of those elements, right? All of those columns are keys, and all of those rows are then held as dictionaries. Okay. So anyway, let's see if I can convert it to a list. This is what I was trying to find, but it does not have that attribute to list. What it can do is maximum convert it into a data frame. So what I could say is that to dict, right? And from to dict, I could take uh, dot get, right? Get, and what I could get? I could get this particular row, which is total cases. So I could say total cases, because it's a dictionary, right? It would be able to give it to me. Okay, and if I just delete it and print this particular thing, what I would be able to get is that uh, dot get an empty dictionary. Why so? I'll just ask it to be stored df, okay, dictionary df, and if I just print dictionary df once and see what it looks like. It is basically some dictionary where I have all of those stuff, right? And in that I have one of those columns as so if I just say df and that hash thing, right? What it should give me is that only that hash one. Okay. But why we are not able to get this total cases? Let's see. Right, I am able to get. Okay, so I am able to get, but those are indexed, right? All of those are indexed, and it is indexed exactly with the these row names that they had. Okay. So anyway, what I could do now is get values from this. So I could just say values, right? Just those simple dictionary operations that we did. And now I will have a dict value iterable, right? This could obviously be simply converted into a list, right? And so I could do that. I did a list, and now I have a list, and now I can apply a map function to it. So let me apply a map function, and I would say map, right? I want to do what? Convert all of them into a float, or in fact a float, lambda x, lambda x, and then I just want to do float of x. Okay. And I want to apply it on this list, right? And that's it. I guess I just want to print it. Right? Print it. So what I would get is obviously when I would print a map function, it would give me a map. So I will print a list it as a list, right? So when I print it as a list, convert string into float. Right? Obviously, now you can see that it's not so straightforward, right? It contains a comma as well. So whenever there is a comma, right, it cannot be converted into an integer or a float. So what I will have to do is somehow remove this comma from here. Okay. So I mean, listen and see this how I'm doing it. Here I have all the values, right? Here are the values, and each of those values, right? Each of those values I am applying a function on it, right? Float x. So before just directly converting into a float this particular x, and I'm converting this is an x, right? At that time, so I'm converting into a float, and that is throwing an error. What I could do was say split, right? Split, okay. So when this would be split, what it would be split at comma, right? And it would give me three lists, one, two, three, right? Because it would split at comma at two places, so this will have three values. Now this three values, I will have to join, right? Dot join. So I hope all of these functions we have seen, so should not be a problem to anyone. This particular thing should be able to convert this back into a float number. Let's try and see. I hope this construct is clear to everyone. This is just trying to write in one line, and you could see that now all of them were converted into a float. And since it is a list now, I could do a sum. So I'm just trying to write it all in one line, but I hope again this is clear, because if this is clear to everyone, then I mean we are good. We're good until now. We're able to get the sum in one line of code, right? Of all the values which were there in total cases. Also, we converted all of those comma separated numbers into a regular number, which we could then sum over. Okay. So this is how you could do some, simple manipulation, right? Obviously, if you wanted to, assign it to the here in a particular column, right? One more column, you could simply do that and say, uh, obviously the dict I don't want to work with dict but the data copy. So I will say data copy and just say sum of sum of I don't know total cases, right? And I would just want to assign it to each of the elements here. Right? So we'll just say, I mean, I can just assign it here because that is how it works. Right? If there is only one value, it will take and assign it to all of them. Okay. So now if I see df underscore copy, in fact, data underscore copy, right? I will be able to see that it contains one more column, right? And it has the same values, sum of total gets repeated over. So I think this demonstrates that how pandas work and how you could do some data manipulation with it, right? I think this is all in terms of how we would use pandas. Um, Obviously, we had more examples where we would use, let's try it with an Excel file because since we can also read XLSX, let's try it with Excel file and then I think we would be good to go. So, read Excel files using pandas, right? So Excel file, I mean, reading it would be very similar. We have just used the dir function and saw that reading CSV and reading Excel should be same. But even then, we would like to see it, and we would say pd.read Excel, right? Excel. This was the function, and as soon as we would pass it some data, it would tell me, right? It would show me IO, basically input output. What do you want to input? So it supports the XLSX file, XLX file, XLSM macro file, XLSD file, ODF file. All of those files are supported. And then it asks you to specify a sheet name. So let's say my net schedule, let me open it once. Right? My net schedule file had, again, this is the same file you used yesterday. It had 3 sheets. Right? Let's say I want to read the second sheet particularly, right? So what I could say first, let me just read Excel by giving the name. So I will just say net schedule, right? Schedule and dot xlsx dot xlsx. Right? This is my file name. Okay. Now that I have read it, I have specified the path. What I can say is that sheet name. Okay. So I can just put a sheet name and then say one, right? So you can either give it an index or a name, right? It's up to you actually. It would work with both. And then I think that is it. I don't think I need to give it something else. If I want to skip rows, obviously I can, and some other things I could do, but not needed here, right? So let me just call it net sch data and try to read it. Now, if I say net sch data, right? It would basically be what is there on the second sheet, right? So it has CSCV, this one has DNH, and this one has some Nasil. So it read this one, right? And then again now it is very easy for you to subset, right? Let's say you wanted to multiply ISGS and STOA values, right, and get it into a vector. So what we could simply do is that ISGS, right? ISGS into what net net sorry net SCH data, right? And what one which one LTA, let's say LTA, right? So it already started giving me some suggestions because this is what it understands, right? So if I just multiply it, it could give me multiply, and then I could assign it to a new column name, right? So net sch data, right? Net sch data, and which column? Let's say I call it last call. Okay, last call, which is not there already. So now my if I just see net sch data and want to see the info, right? What it would do is just now it will tell me that I have one more column called last call, which is floor 64. Okay, right? And so one is net schedule. Sorry, I mean dot info. So what it does is just summarize the D types, right? Data types in the data frame. And one more we have called uh, net sch data dot describe. Okay. So what it does is basically summarizes the whole table, right? Summarize summarize the whole table so that you could have a basic idea again of your data, that what you are doing, right? So it could basically take all of those columns and give you how many observations are there, what is the mean of each of the observation, basically what is the average, what is the standard deviation, what is the minimum, and these are some quantiles, I mean percentiles, basically 25 percentile, 50 percentile, 75 percentile. Again, used for statistics, right? If you want to, and then it gives you the maximum of all the numbers. So again, this allows you to briefly see how your data looks like, right? And then I think that is it. Ultimately, you could subset the same way you saw with normal data frames, right? Ultimately, this is a data frame. So you read the Excel, this is a data frame. You could apply all of those things which you've already done, right? Okay. So we have done with one XLSX file, one CSV file, right? We could, if we wanted, we could read all four of them together and then create one more new file, right? So again, if I just quickly want to see what all this net SCH data has for me, right? What all I could do with it. So it says that you could uh, basically pass it to a CSV. Basically, you could convert it to a CSV, and you could maybe save it. Let's say where the save function is, right? So save. Uh, can't find it here, but should be some. Uh, anyway, so the thing is that these particular functions to Excel, to Dict, right? What happens is that uh, they are the ones which allow you to even export the data. So let me just export it finally, right? Let's say I want to export the final data, right? So my final data, let's say it is net schedule data in which I have added this last column as well. I wanted to export that. So I could say, I don't know which one it was. It's net schedule, in fact, net schedule only. So I could say that net sch data dot to CSV, right? And when I would do to CSV, it would just ask me for a path. So let's say new file, right? New file dot CSV. Okay. Similarly, if I do comma, it asks me other stuff, but I don't need to specify it. If I, do net sch data dot to Excel, right, and say new file dot xlsx, and see other options. You could specify a sheet, right? I could just specify a sheet name and say exported, right? So let's see how both of these work. All of these work. I just refresh it here, and two new files have come. One is new file.xlsx, right? If I just try to download it and see if it has a sheet name called exported, definitely it should have. Right? So you just open in my this, and I can see that I have that. mm, I have that column. Okay. So see, it actually beautified it a bit right before printing it. But then you could see that how easy it was to manipulate a particular file and then export it, right? So this is where the power of data frames actually come when you want to work with so many spreadsheets and then take one data from here, second from here, third from here, do some summing, manipulations, total, all of that, and then finally dump it to some file, which can again then be used to into some other program, right? So you get the idea. But I think this is all I wanted to show you with respect to the pandas, right? And how it allowed you to do complex operations on spreadsheets, various spreadsheets, right? So that is it for today's session. What remains for us is some response parsing and seeing how to fetch data from APIs, right? So we will use some APIs in the next session, right? And also see we have already seen some of the response parsing, but I think if we get more into it, it will be very easy for us to scrape sites because when you're inspecting the elements, the next thing that you have to do is actually parse them in your own Python script, right? So we are almost there. Only two topics left. This we have already done today. So we have used Excel Wings. We have used Pandas. I think both of them together should be able to manipulate any kind of file that we would have come across. So basically, until now only I think you could do any kind of Excel manipulation and basically Excel automation that you would like, right? Only thing, few two topics are left is to just again fetching data, right? And then we will see that. So we have not yet seen interaction-driven web pages and form-driven web pages. That will be our last stop, and then we will in last two sessions we will only do practice size, which will contain all of this using all of this, right? So that is it from my side for this lecture. I hope it is clear to everyone. If there are any doubts, please go ahead. I can clarify them if there are any. And I will just download these two files to share with you. Yeah. So please let me know if there are any issues. That's it for today's session from my side. Okay. Dave and Dhananjay sir, Ramesh sir, any doubts, any issues with today's session? No issues. So I hope others also do not have any issues. Right? That's great. Great. Can you just give me a confirmation, Dhananjay and Ramesh sir, that you had no issues with today's session? And I think then we can conclude today's session and meet tomorrow. All right. All right, everyone. So bye. I think that is it for today's session. I will stop the recording.